I'm going to sail through this example because it's just like the previous one. In this case, f is concave down, and we have two values, f of 2 equals -6, and f prime of 2 equals 2. What is the estimate of f of 1.8 used in local linear approximation? So, local linear approximation, that tells us that we're going to be doing tangent line work, and so we need to know the equation of the tangent line in point-slope form. Y minus f of a equals f prime of a times x minus a. I hope now you're seeing why this is my preferred form, because now we know a is 2, so I'm just going to replace that. Y minus f of 2 equals f prime of 2 times x minus 2. And we know f of 2 from the question is -6 and f prime of 2 is 2. And so y minus -6, so y plus 6, equals 2 times x minus 2. All right, so now we have an equation. Our next step is that we need to use local linear approximation to estimate f of 1.8. So we're going to say f of 1.8. We have to plug in our x value of 1.8 into the equation that we have here. So we do y plus 6 equals 2 times 1.8 minus 2. Now you'll see here, 1.8 minus 2, that's going to give us -0.2, so y plus 6 equals 2 times -0.2. Y plus 6 equals -0.4, and we subtract 6 for both sides to give us y equals -6.4. So now we have our estimate. We can say that f of 1.8 approximately equals -6.4. Now, is this an overestimate or an underestimate? That's the final part of the question. Overestimate or underestimate. The question tells us that our function f is concave down, which means that our function would look something like this, and our tangent line would go like this. What do we notice about our tangent line? It's always above the function. Since it's above the function, this -6.4 is, I'm going to write this in yellow because it is an overestimate, because f is concave down. Because our tangent line is always where? It's always above when it's concave down.